Hey there, Mrs. Glad here, and I wanted to do a video finishing our notes from Unit 2 because there's some special cases that if you are not here in class for, or maybe you need a little refresher on, I think will be very valuable. So using that yellow note packet, I'm going to be on page 6 and 7. So if you have that, go ahead and pause right now and find that yellow note packet. Again, page 6 and 7. So last week, actually, was on Monday, we went through page 6 and we filled in I can solve multi-step equations with variables on both sides. So here's what we want to know. We want to get our variables together. In order to solve, we need to combine all of our variables together on the same side of the equal sign. So we did fill this part out already. So just double check that you have that on the top of page 6. Variables on both sides. All numbers need to move to one side, and all variable terms need to move to the other side. It's a pretty important concept that we'll be working through here today. So on page 6, I'm just going to do a couple, just to make sure that we are all on the right track. I'm going to do letter E. So please join me. I'm on the bottom of page 6. We're going to do letter E. So letter E, if you please notice that if I find my equal sign, it's right here in the center. I've got some work to do on this one because ultimately my goal is to get the x all by itself. And if you notice, there's 3 x's on the left and 6 x's on the right. Well, what I need to do is notice that there's x's on both sides, but there's also some other business going on, like these terms that can be simplified. So here I've got 3x on the left, 6x on the right. So what I want to do first of all is I want to move all of my x's to one side or the other. So in class we've been saying to eliminate one of our variables, we pick the smallest one to try to avoid some negatives. So this 3x, to make it eliminate, I'm going to go minus 3x on the left, and then I'm going to come over here and do minus 3x on the right. Now I'm going to go ahead and balance these off. So here's my first teeter-totter. So my 3x's are going to eliminate. A positive 3 and a negative 3x cancels. So I'm left with 3 minus 15 on the left, which is equal to 2, and minus 2x is plus 3x plus 1. Now, I'm going to do a little bit of simplifying here because over on the left, I've got nothing else to do with my terms, but I can go 3 minus 15, which I know is equal to negative 12. And on the right-hand side, I can put this 2 and this 1 together to give me 3, so it's 3 plus 3x. So I've combined my like terms. Now I'm ready to solve. So I want to get the x all by itself. To do that, I'm going to reverse PEMDAS, and I see that over here on the right, I have my x, so ultimately I'm going to have my x equals by itself. So I've got a times 3, and I'm adding 3. So reversing PEMDAS, I start with adding and subtracting first. To undo this, I'm going to subtract 3 on the right, come over here, subtract 3 on the left. I'm going to draw my second balance beam. So there's my teeter-totter. My 3's now go ahead and cancel. So I'm left with 3x over here on the right, which is equal to negative 12 minus 3, which is negative 15. Oh, we're really getting somewhere. Looks like I've got just one step left to get that x alone. I'm going to undo the multiplying by 3. Please divide by 3 on the right. Divide by 3 on the left. 3 divided by 3 is x, or 1x. And negative 15 divided by 3 is negative 5. So here I've come up with my solution, and I can easily put a negative 5 times negative 5 on the left times negative 5 on the right, just to check to make sure that all of that makes sense. And if I put a negative 5 here, I'm just going to put it down a little bit lower. Negative 15 plus 3 does equal negative 12. We've checked it. It works. So that's definitely a little bit more complicated. If you flip to page 7, let's do one of those level 3s there, and then we're going to get to our special cases. So on page 7, flip to that side. Let's do letter H. Letter H is a level 3. We actually did G on Tuesday in class. So I want to specialize in letter H. So lots going on. I want to find my equal sign and find the center to my equation. There it is. Now, before we can isolate our variable, I see they're on both sides, we've got to clear out those parentheses. So let's simplify using the distributive property, 3 times x, 3 times 4. On the right, negative 2 times x, negative 2 times the subtracting 10. So I'm going to simplify. 3 times x is 3x, plus 3 times 4 is 12. Over here, I've got a plus 4x. So right now, that is balancing to equal negative 2 times x is negative 2x. Negative 2 times the subtracting 10 is a plus 20. And don't forget at the end here, I've got a plus 10 waiting to be used. So I have now distributed, got rid of my parentheses. Now we've got to do a little bit of work over here. I see a few things that we can do. So first of all, if I'm looking at my variables, I've got a 3x and a 4x over here. So I'm going to combine them to give me 7x plus 12, which is all equal to, over on this side, I've got negative 2x. And while I'm combining some like terms, I might as well put my 20 and my plus 10 together to give me plus 30. All right, so now we've got a bit of a problem because we've got 7x's on the left and I've got negative 2x's on the right. But what we want to do is we want to aim for the smaller variable to eliminate, to take it off, so that we can have our variables on just one side. So I'm going for the negative 2x. I'm going to eliminate it by adding 2x on the right, which means to keep it balanced, I'm going to add 2x on the left. I'm going to draw my line. So now a negative 2x and a positive 2x, oh, this is really cool. These cancel, they eliminate. So on the right, I have 30, which is balancing over here with 9x plus 12. So 9x plus 12 equals 30. Now, we are at a two-step equation, and I can see that I want to get that x all by itself, so I want x equals. To get that x by itself, we've got to undo the operation of multiplying by 9 and adding 12. So let's reverse PEMDAS and get rid of that 12. Step 1, minus 12, minus 12. I'm going to draw my second teeter-totter to balance. My 12s eliminate. I'm left with 9 times x equal 18. Now, it's really shaping up. I can see that this is going to work out pretty nice for us on this one. To undo that multiplication, to finish this off, I'm going to divide by 9 on the left, and then I'm going to divide by 9 on the right. So 9 divided by 9 is 1. X equals 18 divided by 9 is 2. Nice work. That was complicated. Definitely a level 3. A lot of skills going on in there. Now, if you can join me with these last ones on the bottom of page 7, here is kind of some special situations that we need to take note of. So you're going to see here, well, isn't that special? Yes, coming up, this is going to be super special. So on page 7, lower half, it says, what's up with these? So let's take a look at letter A. Letter A, the thing is that when you start solving, you really don't know what you're getting into until you actually start the problem. So you would look at letter A and let's just solve like we always would. Find your equal sign, put your line in. Okay, well, I've got 2 x's on the left and 2 x's on the right. Well, notice that one isn't smaller or larger, they're the same. So it doesn't matter which one we choose. Let's just go with the left. To remove, I'm going to go minus 2x. To remove on this side, I'm going to go minus 2x to keep it balanced. Draw your teeter-totter. Well, there it is. Now, watch what happens. Positive 2x, negative 2x cancels. Positive 2x, negative 2x cancels. Let's take a peek at what's left. 3 is balancing with 7. What do you know about 3 equals 7? I hope you're saying it can't. That's not true. When my variables cancel out here, 3 does not equal 7. So we make this mark of not equal. They are not equal. So that means that in this equation, this might be the first time this happens, there is actually no solution. So that means for whatever number I pick for x, if I put a 1 in on both sides, if I put a 1 here and a 1 here, these would always cancel. It would be 3 equals 7, not true. If I put a 10 in for x on each side, my x's would always cancel out, and I would be left with 3 equals 7, which is not true. No solution. So here, when our variables canceled out and it's equals to two numbers that are not the same, we know for a fact that there is no solution to this problem that exists to make it true. So here you go. First problem that has no solution. Now, let's take a look at letter B. Find your equal sign. Put your line in. So notice here, we've got a bit of work to do on the left using the distributive property to take 3 times x, 3 times 4. I get 3x plus 12, which is equal to 3x plus 11. Well, I'm going to keep on going here, and I know that I want to get my variables on the same side, so I'm going to remove my smallest variable. Again, they're the same, so it doesn't matter which one is smallest, they're both the same. I'm going to subtract 3x on the left, subtract 3x on the right. I'm going to draw my teeter-totter. Well, look what happens again here. My 3x's cancel, my 3x's cancel. Now look what's left. 12 equals 11. Well, hopefully you're saying that's not true. 12 will never equal 11. There is no solution. These are not equal. So again, there is no solution for this problem. So no solution exists. That is how we would answer that one. Let's look at our bottom two. So down here, I have this. Whoops, goodness, I've got to come back here. There we go. Okay, I was going to try to move this, and it was being finicky. There we go. So let's take a look at letter C. So letter C, once again, I've got 2x plus 3 equals 2x plus 3. I'm going to put my line in and solve. And maybe some of you noticed, but hey, they're exactly the same on both sides. They're identical. So if I didn't notice that they were the same, and I wanted to eliminate one of my variables, I would go minus 2x on the right. And watch what happens this time. My 2x's cancel. So now we're balancing. Over here on the left, I've got a 3. And on the right, it's saying it's equal to 3. What do we know about 3 equals 3? That is true. So here, 3 equals 3, that whatever we cancel out, I know that this equation will be true. So it's going to be true for any variable of x. So right here, whatever number I put in for x, I will always get the same solution on each side because both sides of my equation are the same. So let's just say that I put a 1 in for x. So 2 times 1, 2 times 1. 2 times 1 is 2, plus 3 is 5. So here I get 5. 2 times 1 is 2, plus 3 is 5. 5 equals 5. It's true. Let's say I put a 10 in for x. So 2 times 10 plus 3 equals 23. If I put a 10 in, same thing, 2 times 10 plus 3 would be 23. See how it will always be equal no matter what number we put in for x. So because it's true, this solution, x, has infinitely number solutions. It's like a sideways 8. So there are infinitely number of solutions for this problem. It is endless. It will never end. X could equal 1, X could equal 0, X could equal 5, X could equal 1,000. It will always be true. So infinitely solutions is what we say. There's an infinite number of solutions. So right here, X is infinite number of solutions. And this last one, again, a lot of times when we have these special ones, you won't know it until the last minute. So here I'm going to share the -2 with the X, the -2 with the 3. I've got -2 times X minus 6, which is equal to -2x minus 6. Now, take a look. They are identical on both sides. If they're identical, no matter what number I choose for x, let's say I choose 0 for x. So if I put a 0 in here and a 0 in here, 2 times 0 is 0, minus 6 is -6. -2 times 0 is 0, minus 6 is -6. Here it is. It is true. So here again is a solution that we know because they are the same on both sides, there is an infinite number of solutions. So there's infinite number of solutions for x. We could put any number in and it would work. Those are definitely special circumstances. So at the very bottom of your note page, if you check this out, there are actually 3 possible solutions for every equation. We have been studying the most that have exactly one solution. There's one number that makes the equation true. Maybe it was x equals 10. Done, it checked out, it worked. But new today, it is possible to have no solution. There are no numbers that will make the equation true. That usually happens when you have something that's false. Maybe it's 3 that does not equal 1. So it's false. So we say no solution exists. The shorthand, the little symbol, is a 0 with a line through it. That means no solution. And the last one, when 2 equations are the exact same on both sides. Let's say it's 2x plus 1 on the left, 2x plus 1 on the right. There's infinite number of solutions, so you can answer it by saying there's an infinite number of solutions. You can write it out. You can do that sideways 8. Both work. So we've got all kinds of new possibilities. This is something that is brand new to us, and we will continue after. So thanks for watching.